If you remember, we did IPsec and IKey fundamentals last time. What are the VPNs?
Yes,
Complete
yes.
overview of site to site. So today we are going to continue with that. We'll start with site to site VPN. How you
Okay. Actually, I have one question.
Okay, good.
What is difference between the session key and pre-shared key? Pre-shared key is which is we are giving into phase one and which is given on the side to both side, right? And right, no?
Yeah, right.
Yes. And the session key will be encrypted once the phase one is completed.
Yes,
This
so
is what is
session
my
key will be the key which will be used to encrypt your data. Used in phase two. Pre-shared will be act as a session key for phase one.
okay. Okay, which is in terms of the administrator, system administrator, they both are the knowing that pre-shared key, right?
Yes.
And that session key will they would not be understand the session key because it's in encrypted format.
Session key will be taken care by DH group. Pre-shared key will be taken care by your admin.
Okay. Okay. That's fine. I can understand it.
Right.
Yeah.
So today in this example, what we are going to do, we are going to configure VPN between this guy, which will be my R1, and this guy R3. We are representing their LAN networks as a loopback. So it's going to be loopback 1 and it's going to be loopback 2. Same thing goes here. Loopback 1 and loopback 2. So your encryption should be end to end, both the direction, using side to side VPN. All right. Well, let's see this. So this is my R1 router. This is R3 and this R2 is going to act as an ISP. All right. So the basic prerequisite before establishing the tunnels is I want to make sure that when to end reachability is there. So I'll ping R3's IP, which is 192.1.20.3. So fast Ethernet 0 by 1 is the IP, which is having 20.3. Get this one. So this 23.20.3, let's see, is configured here. Okay, end-to-end reachability is there, so I can now configure the VPN. So just to show you what I have the loopbacks configured, and I must be having a default route. That's all. I don't have any route for these loopbacks. So for example, if I want to show you loopbacks of R3, okay, so I only have the default route, no route for the loopbacks, which basically means I cannot ping the loopback address of R3 from R1. Right, because we are representing it as a private network. So even on ISP, he must not be aware about the loopback addresses. Why? Because these are the private addresses. So even ISP don't have these loopbacks in his routing table. Okay. So let's start with the configuration. Let me take out the notepad. I'll be configuring phase one first. Crypto second policy 10. I need to define the encryption algorithm. I say encryption will be using AES. For hashing, I will be using MD5. Group, which will be generating your session key. Let's say group 2, you can say group 5 or group 8. It basically brings how much bit you want to use, right, to generate the session keys. So as a standard, we'll go with the group 2. And one more thing, which is lifetime, the validity of your phase 1 tunnel. So by default, it's 3600 minutes. I'll keep it same 3600 minutes. Now, the last thing, which is your authentication. Here I'm saying for authentication, I'm going to use pre-shared key. It's just the type which I have defined. I have not defined the key yet. In next step, I need to define the key. Crypto IC camp key. I want to put key in clear text. So I'll say 0, Cisco, and address of my neighbor. This is the configuration on your R1. And address is 192.1.20.3. This is my phase 1. Once the session key is exchanged, now I can encrypt my actual traffic. Crypto IPsec, sorry, because ISACAMP is your phase 1. Now I want to encrypt the actual data. Crypto IPsec transform set tset. I need to have encryption and hashing algorithm defined here. You have two protocol to go ahead with that. One is your ESP, another is your AH, authentication header. The difference between ESP and AH is that AH only gives you the authentication capabilities, where ESP gives you authentication plus encryption. So AH stands for your authentication header, and ESP stands for your encapsulating security payload, which will be encapsulating as well as encrypting as well as authenticating your entire data. Mostly we'll be using ESP all the times. I'll say ESP, AES, and I will use ESP for hashing as well. SHA-HMAC is the hashing algorithm. ESP, AES for my encryption. Where is my key? Key is this thing which I have already shared in my phase 1. So this is my phase 1. This is my phase 2. Now, since it's side to side VPN, I need to define my interesting traffic, which traffic I want to encrypt. So I have two loopback addresses on each, and I want a full communication so that both the loopbacks can ping each other. I will do it with the help of an access list, an extended access list. Let me show you. Access list 150 permit IP. Then what is my source? 168.1.0 going towards 192.168.2.0. I also want a communication between 1.0 to 172.16.2.0, right? This is my forward communication, which basically means I have defined the access list for these two on this side, right?
Yes.
Is that okay?
Yes. Yes. This is the standard access list, right? It is not extended. We can use that extended access list in this. Hello, am I audible? Hello.
Sorry, I was talking on mute. Can you come again with your question?
Yeah. This we can use that extended access list, or this is what we have to do.
This is extended only, so you have to use extended because you need to define source and destination both.
Okay. 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 Yes. Yes.
All right.
Actually, I wanted to know that I wanted to give it a name instead of this
You
number.
can do that as well. You can give your name any name. That's fine.
Uh-huh.
It's
Okay.
ultimately router is the standard ACL. It's nothing specific with IPsec. You can
Uh-huh.
say access list extended ABC, and then you can give your permit and deny statement. Same thing.
Okay.
All right. So three things so far. This is your phase one. This is your phase two. This is your interesting traffic, which you are defining using an extended access list. The last thing to combine them all is basically the second last thing is your crypto map, where you will be combining all these things. I will say crypto map, give any name. I will give a name C map, sequence number 10, and I'm saying take the session key from the ISACAM tunnel. Basically this. So when I'm clubbing them, I'm clubbing the session key with this statement, IPsec ISACAM. Now I will say match address 150. If you want to give a name, you need to call your name here. Match address 150. Then set transform set. What is the name of my transform set is T set. Okay, I will call that name here. Set peer. Basically, I'm saying if this is my interesting traffic, encrypt it or basically secure it by implementing this transform set and send it to the peer to my R3. What is the address of R3? It's 192.1.20.3. Once everything is done, you need to apply your crypto map to your exit interface. Crypto map CMap. This is the crypto map name, which I'm calling under my interface.
Okay.
All right. So that's the all config which you need to do on your R1 router. Let us go ahead and do that. Now I will be doing the same thing for R3. I just need to make few changes. It's going to be 10.1. Let me just quickly verify the IP address on my R1 should be 10.1. Yeah, it's 10.1. The next thing, I just need to flip the ACLs. Source becomes destination and destination becomes source. And here also I'll say 10.1 is my peer. Rest everything remains the same, it's just the interface is faster than 0 by 1. All right,
Okay.
let's do it for R3. This is my R3. So from R1 loopback to R2's loopback, now communication is happening.
Yes.
Okay. Okay, there is no, okay, loopback 2 is there. Let's see. Okay, so I have not defined the access list for this loopback or this subnet. So what I've
Ah,
defined, I'm saying whatever is going from 192.168.1.0 is able to communicate with these two subnets, which is happening in here. You see, we are able to reach 2.1 and we are able to reach 192.168.2.1. But when I'm trying to reach 172.16.2.1 with a source of loopback 2, right, means this address, which is not in my ACL, it is not happening. So it says if you want a communication between the subnet, it has to be there in your ACL, or in another way, you can say ACL gives you or tells you what is your interesting traffic. So that's how you establish your VPN with your interesting traffic. Now, if you want a full communication, you need to create two more entries with a source of 172.16.1.0. Destination is there. So total four statement on each side in ACL. Now, if you want to see your encryption is happening or not, I'll show you. Before that, this is your phase one, how you check your phase one stats. It says the phase one is up with this source R1, the destination is R3. The state is idle because the key has been generated and shared across. After 3600 minutes, it will come up again and will share the keys and will go again in the idle mode. So this is the expected outcome. If you want to see where the encryption is happening and the encapsulation is happening, you can see here for this subnet where your source belongs to 1.0 and destination belongs to 2.0 subnet. Okay, you have encapsulated 14 packets and encrypted 14 and decapsulated the same. It also gives you what is your exit interface and local and remote endpoint. So your tunnel is now already built up between from where to where, from this side to this side, a secure tunnel. These are your logical tunnel. If I show you, is there any tunnel interface? No, because you are using your exit interface. There is no tunnel interface because you are using exit interface and defining traffic using the ACLs. So this is your site-to-site VPN, a point-to-point VPN.
okay. Uh, Later we'll discuss about the access list, right?
What
because
I didn't get what is access list discussion?
actually I wanted to understand the access list more, right? What is difference between standard and extended, and
It's same. It's
how
it's
we
the
can.
basic what you are already aware. It's just a CCNA. It's just you're using a ACL here, right? There is
Uh-huh.
no change in ACL. ACL
Okay.
still stands the same. It's just the basic CCNA ACL.
Yes, I know that.
Means we are
I
not
am
using
using that,
any.
but I don't know why I'm using that.
You are using name-based
Yeah,
ACL.
actually,
That's same
yeah.
thing, right?
Yes. Actually,
It's same. It's just the
yes,
syntax is changed for your extended ACL.
yes.
There's a difference in ACL when you do it on ASA, which I will tell you. ASA doesn't understand wildcard mask; it only understands the network mask.
Uh-huh.
So there is no ACL difference on router side. It's the same router 37 series router we are using.
Okay. No, actually, I didn't gone through it. I whatever I'm doing, it is just an uh, which is understand I understood by me on the internet or surfing somewhere, right? Though I am CCNA, CCNP certified, but I didn't, actually, I wanted to make an understanding of that access list part. Hello, am I
Do you have any
audible?
question? Because I'm not getting what actually you are
Uh,
looking.
okay, yeah. Uh,
If you are looking for a syntax, I can show you the syntax if you want how you configure extend access list. You give any name and then you give your permit declare statements here. Permit, you can configure. Yeah.
okay, so but okay, right. So now we have configuring this extended access list. So what would be the if I wanted to deny some packets, right, or deny some network, right? So what would be the sequence for that? I want to permit something and I want to deny something. So what would be the sequence for that?
Okay.
Yeah. So those things I actually I'm not that much clear on that part. That's why I'm asking it.
That's how you do it. You give your ACL name and then your
Yes.
permit and deny statement. By default, the sequence is 10 for all. If you want to see your access list,
Hmm.
so it's going to take the way which you have configured it from top to bottom, any access list.
Okay.
So that's how I configured using value, and that's how you do it using the name. Ultimately, it's same. No one can tell from at this point that how you configure it. It's just the name or number or how you want. But as you asked how it goes, how to define the sequence, it takes the sequence 10 on its own. So whichever you comes configures first will come on top, and later how it goes.
Okay. So if I wanted to deny, then it should be on the list of the uh, list, right?
Yes.
Okay. Okay. Actually now I'm clear in this.
Okay. So this is your site to site
And
VPN.
same thing goes for the standard one, right?
In standard, you cannot define your destination. You can only define the source.
Okay. Okay. For the standard, we cannot depend the source. Okay. So why we use the standard and extended?
Nowadays, I don't see we are using standard anywhere. Even I don't see we are using ACLs. It's firewall everywhere.
Uh-huh.
Standard we generally do when we have too many source or too many destination where we want to deny. But those were early old days, not now anymore. So
Okay.
in real
So.
environment, you will only see the policies on firewalls, not
Mhm.
even these ACLs on routers or switches.
Okay. Okay, that's fine. And that apart from this, that sometimes let's take an example that we have created this ABC extended list, right? And we are going to put this on the interface. So there are two options, that in and out. So what is that actually?
More on ACL.
Yes, that's why
So
that's why
uh,
actually firstly I asked you that later on we will
mhm.
cover this.
Let me tell you. So if you are saying that I want to deny when someone is going from 1.0, 192.168.1.0 towards 2.0, basically means you are on R1 router, and when someone is going towards R2, you want to deny it. So you will apply your ACL on this interface in out direction. So that in and out defines the direction of the traffic, whether it's incoming traffic or outgoing traffic.
Okay.
So you need to say access group, whatever name is ABC,
Hmm.
and it out direction on this interface.
Okay.
In ASA, we will be configuring ACL. Probably that would be direction will be clear by that time.
Okay, that's fine. That's fine. Then no issue. That's why I ask you. Sorry to
ACL will see there how
this.
ACL is.
Uh, Sorry to for these basic questions.
No, no.
Actually, I am not. See, whatever I am having the 13 years of experience, but actually I am into not into security fully, not into networking fully. I am doing everything actually. So
Okay.
I'm
Mhm.
actually I'm doing servers. I know Linux, I know routers, firewall, everything, right? But those are whatever I learned. It is from the internet only. I didn't learn from the particular classes or somewhere else.
Mhm.
Yeah, this is what I am doing. But I am doing
Okay.
pretty much very good into that area.
Okay, great then.
Yeah.
All right. Okay, so this is our site-to-site VPN, means one site is communicating with another site, so that you call it site-to-site VPN. So I will stop this and I will move to the next lab. Okay, so before moving to the next lab, what I want to do you give you a task. What we just saw is your site-to-site VPN, where you have two devices, two routers communicating with each other. Now, see, what I am going to tell you is just for your practice. In real environment, there's a lot better way of doing all the same things.
Mm-hmm.
So you will not see this in the production or in the real environment, but it's good for your practice purpose. What is the task for you? For now, what I just configured, I configured a VPN between this device and this device, one and two. But what if there's a R3 device as well? So task for you is to configure side to side between R1 and R2, what we just did, and also R1 and R3,
Okay.
not between 2 and 3. Just there's the task. Now, though I have already configured it, I have already shared the. I'll share it this lab with you. So if you go to site to multi-site, solutions are already there. So here it's R1 and this is R3 and R5. You will be configuring the tunnel, the virtual tunnels, sorry, the logical tunnels or the VPN between R1 and R3 and R1 and R5. Just one difference, AC entry need to be created for both the side, and you need to have two crypto map. One crypto map, basically one crypto map, but two entries in it. So 10 is the sequence number, 20 is the sequence number, which is the differentiator. So you will be having two entries in the crypto map, one for the flow between R1 and R3, another one is for the flow between R1 and R5. No changes with respect to the configuration on R3 and R5. There's only one change on the R1, which is the crypto map sequence and the ACL entry. Plus, you need to define pre-shared key on R1 and R3 and R1 and R5. So that's the task for you.
Okay.
Okay. So just give me 2 minutes. I will be quickly back. Meanwhile, you just can have a look of
Yes,
this set
yes.
and let me know if you have any question. And do you have Eve installed on your system?
No, actually, right now I don't have
What is the RAM of your laptop you're using?
it is 12 GB,
Okay, then
12 GB, and I do have the SSD.
okay. So I think that should be fine. I will after the class I'll share the email with you. It will be having a drive, Google Drive link to download this Eve setup, and also I will just share these labs with you so you can directly import and start practicing on this directly.
Okay.
Okay. So when you will be opening that Eve, you first need to install the Eve, the basic setup, and you can import the labs. So it's
Okay.
just a zip file, and importing is easy because how you do it. So this will be the UI you will see after the installation. Just go on this tab, import and browse. You will be able to import all the labs which I'll be sharing with you, and I'll be sharing all these labs which is there in the bottom. So this is I have made only for the student purpose. So what they can do, for example, you want to do DMVPN today, right? You just need to click on DMVPN. The basic underlay is already configured, which basically means this IP address schema what you are seeing here is pre-configured. The solution is written on your screen. So this I have done for your VPN labs and ASA because these are the only two, uh, should I say, devices or technologies which you can test. Apart from this, you cannot. Laptop doesn't support that much capability because VMs like FTD or ICE requires one single device requires, as per recommendation, 40 gig of RAM. So that I will be doing on sometime on real device and sometime on virtual. But yeah, for the self practice, self learning, you can leverage these two labs on your lab.
Okay.
Okay. Okay. Give me 2 minutes. I'll be back. Okay. I'll open that side to side if you want to review the config.
Multi-site, not this one, I think.
Or if you want to take the screenshot, you can go.
Okay. Okay. Yes, I already taken this snap.
Okay. So side to side is done. Multi site is your task. Next thing, what I want to have a look is your communication between two sides, but now we are doing it based on a GRE tunnel. So these are the two sites connected via internet. What I want to create a GRE tunnel here, a tunnel interface. This is going to be your logical interface like your loopbacks and one tunnel here. Once the tunnel is up, I since these are now virtually connected with each other, right? So if I am having IP address, for example, 192.168.1.1 here, I can configure 1.2, 1.3, anything from the same subnet here, right? Okay, you getting me?
Okay. Yeah. Yeah.
Okay, now once these are now connected with each other, what I can do, I can run any sort of routing protocol, whether it's OSPF, RIP, EIGRP here over this link.